Now, after completing this table, okay, we need to do question 2b. It's a 2-mark question, and it needs to I need to state which transformation linearize the data best and just find my answer, okay, using appropriate stats. Okay. So looking at the table, okay, in this transformation, the log relative risk transformation, I have 99.99%. The R square value is 99%. It's very accurate. So compared with others, it's not that accurate. So what I would say is the log relative risk transformation is the best. Is the best. Why it is best? I need to write the equation down. Equals to. So just copy down the equation. You get 1 mark for this. Because the R square value is going to be 99.0%. Done. Okay. You get 1 mark for telling me log relative risk is the best and stating the equation. Okay. Remember, if you don't state the equation, if you don't rewrite the equation down in this form, you won't get that 1 mark. You get the other mark by telling people that R square of this equation is 99%. This is the reason it's accurate. Okay. Question 2c. Okay. We need to use the equation interpreted the slope of the least line. Okay, we need to interpret the slope, okay, of this equation. Okay. Now, the slope, remember, for those who forgot, y equals to a plus bx. The slope is b. Okay. The slope is the number that beside your independent variable. Okay. Some people they write down y equals to bx plus a. Okay. The b is the number beside x. It's not always the first number. It's the number beside x. Okay. So in this case, my b is going to be 0.0746. However, when we write it down, okay, we write down this. So slope, we don't write down b equals to. We write down slope is positive 0.0746. Okay, so what it means? Okay, remember the meaning of slope? Okay. Now, I write down like this. Okay, there is 0.0746 okay, increase in the y value. Now look at our equation. Okay. The y value changed to log risk. So we can't write down relative risk. We need to write down log risk because we transformed it. Okay, we changed y to log y. There's this much of increase in log risk. Okay, for every increase in the dependent variable. Then we look at our equation again. That's our independent variable. The independent variable is speed. Okay, we did not change it, so we just write down speed. So to be more precise, there is 0.0746 increase in log risk for every kilometer per hour increase. Look at the unit of the value, kilometer per hour increase in the speed. Okay, so to be kilometer per hour increase in speed. So the idea is the slope is your b value. If it's positive, it's increase, or it will be decrease. It's negative, it will be decrease in the y value. Okay, in this case, y value changes for every increase in x value. Okay, that's the formula to explain what is a slope, the meaning of the slope. You need to write all this down in order to get 1 mark this time. Okay. In the end of year exam, this will be perhaps a 2-mark question. So you get 1 mark for labeling the slope, you get 1 mark for the appropriate explanation in sentence. Okay. Question D. It says, without referring to R and R square, explain why it would not be appropriate to use the quadratic transformation of y, which is relative risk square, to linearize the relationship. Okay, this is a really trick question. So the idea is we go back to here. Just experience as a different data. Now we go back to our original data, okay, from the calculator. Now we go to the scatter plot. That's x, that's y. Okay, let's look at the original data. The original data looks like this. Okay, and now, and also have a look. What does the transformation? Sorry. The transformation. The transformation of y square or risk square. What does y square do is, just let me write it down. Relative square is y, risk square is y square in this case. Okay. Now, remember you need to go to your knowledge book. It should be notes regarding this. It should be notes like this regarding it. Okay. With x square, what's happened is we stretch all the x value horizontally. Okay. With y square, what we do is we move up. Okay. We stretch the y values up. Okay. The meaning is, by looking at this data, if I want to make those lines linear on a straight line, what I should do is I should drag those points, the y value downwards. I should compress it, the y value. However, the transformation of y square, according to Knowles, makes the value go up, which is opposite than what we want. Okay? So in this case, that's the reason. So what you would do is, okay, in order to get without using r and r square value, you need to explain it in this way. Okay? So the transformation of risk square stretches y value, stretches risk values. We can't use the y value. Okay, relative risk values. Okay, up. However, However, from the original original risk and speed from original XY scatter plot. Okay, we need to compress the y value, not the risk value. Okay, so which is opposite to what we want. So transformation of risk square does not make does not linearize. Okay. Linearize the data, the scatter plot. So this is, well, in this SAC, is last year's SAC, this is 1 mark question. However, in the end of the exam, for this much of explanation, you get at least they put 2 mark questions, two marks in there. Okay, you get 1 mark for explaining what does the transformation of risk square or y square do, okay, because it stretches the y value up. Okay, then you get 1 mark for explaining what we need to do after reading the original scatter plot. Okay, so that's question D.